Oh, welcome, my friend. Finally, we're here in the heart of the real analyze. In this very first lecture, I'd like to get you familiar with the basics of linear analyze. Now, if you are already familiar with terms like linear regression and regression coefficient, and you also know the interpretation of models as well, then probably you can fast forward and head to the practical part of this chapter. However, it's highly recommended that you take a few minutes to watch this video and make sure everything you thought you know for sure. Now, let's get down to business. Generally speaking, linear analysis, or more scientifically, linear regression, is an approach of modeling a relationship between a scalar-dependent variable y and one or more explanatory variables x. When there is only one explanatory variable, we call it simple linear regression. On the other hand, the cases where more than one explanatory variable exists are called multiple linear regression. This is what a simple linear regression model looks like. And this is its graphical representation. On the horizontal axis is the explanatory variable. On the vertical axis, you can find the dependent variable. Each of these dots represents a record. This line here is generated by the regression analyze. It represents our model. Generally, the closer the line is to the data dots, the better the model is. This is a multiple regression model and its graphics. The graph looks more fancy. It's because for every variable you use, you need an axis to represent it. That being said, for a model with two explanatory variables, we will need three axes to demonstrate their relation. That is a 3D plot, as this one. And you can see the model doesn't predict a line anymore. It became a curved surface. So what happens if we got more than two explanatory variables? Well, then you will need a 4D or even higher dimension plot to represent it. In short words, you can't present like this. However, there is still a way to show how the model is doing. That is, a plot of observed value against the real value, like this one. That being said, let's look at something more specific. This is an example of estimated regression function. You can tell it came from a multiple linear regression since there are more than one explanatory variable. What you must know is the meaning of the regression coefficients, these numbers before these variables. Be careful when interpreting them. For example, this one means, given all other variables fixed, the expected change in y for 1 unit change in x is 0.8. Got that? Well, this interpretation is almost always true, but indeed it only applies to qualitative variables. If you came across variables that do not allow for marginal change, like a dummy variable, then this interpretation won't stand. Well, if you don't know what marginal change is, you probably don't need to worry about this. Now you are fully prepared to dive into business analysis. Let's go!